this module, we begin to explore the software-defined data center, or the SDDC, and how virtualization makes this happen. The modern virtual data center relies on some fundamental building blocks. Just as physical data centers require servers, storage appliances, and cables for networking, virtual data centers rely on virtual compute, storage, and networking. vSphere is VMware's solution at the heart of the SDDC. In this module, we start our exploration by looking at the role of the ESXi hypervisor and the virtual machines in making this happen, as well as the use of the vCenter server appliance to manage and coordinate this environment. This week's labs begin by introducing you in NetLab 1 to the vSphere client, which will be our primary means for engaging with the vSphere environment. In NetLab 2, we will continue to explore by learning how to install one of vSphere's fundamental building blocks, the ESXi hypervisor. In preparation for this, make sure to read Module 2 in the book, which will provide the necessary concepts that will help you to understand more fully some of the procedures that will follow in the labs. Here are some important terms and concepts that we will cover in Module 1. The hypervisor. This is at the heart of a virtual data center. Traditional data centers rely on many physical servers, each requiring a single operating system, such as Unix, Linux, or Windows Server, to manage hardware and support the operation of a role or service, such as a web application, database, or file server. This more often than not wastes server resources, compute, memory, storage, and network, because many of these services sit idle until called upon and only need to use the full capacity of the server during high usage periods, such as at the end of an accounting cycle when financial reports have to be run. To increase efficiency, we want to run many applications, services, and roles on each physical server, each in its own computing environment, so that they do not interfere with each other. Also, we want the flexibility to only run what we need when we need it, and to balance resource usage by shifting the workloads around between physical servers on demand. To accomplish this, we replace the OS installed on the physical server with the ESXi hypervisor, and run our workloads in individual virtual machines on the server managed by our hypervisor. Here we see a simple vSphere environment. It includes 2 ESXi servers, the vCenter server for orchestration, our data store, and a client computer for accessing the vCenter server, all of which are connected by multiple physical networks. So what is a virtual machine, or VM? It's a software-based computer that provides all the functions of a physical computer, but replaces physical components such as CPU and memory with files. The hypervisor uses those files to run the VM in its own self-contained process on the physical hardware, balancing each VM's requirements to ensure each application running in a VM receives the resources that it needs. And just like a physical server, each VM is composed of virtual hardware representations of memory, CPU, storage, networking, etc., upon which is installed an operating system, which in turn manages the VM's workload, web application, database, etc. To enable the VMs and their server workloads to communicate with clients requesting services, both with each other in the case of multi-tier applications, and with the host hypervisor for management, each ESXi hypervisor also includes a virtual switch. The virtual switch, which resides on the ESXi host, can then connect directly through the host server's physical network ports to the data center's physical infrastructure, including network cabling and switching. So where do we store the VM and its files, as well as any other necessary software, including ISO files for installing operating systems on the guest VMs? Typical servers include 500 gigabytes or more of internal storage, and the ESXi hypervisor has a very light footprint, less than 400 megabytes after installation, so excess capacity is used by ESXi as a data store, a virtual storage location for the VM and other files. And because it's formatted with VMFS, vSphere's native file system can easily be shared between multiple ESXi servers. Couple this with vSphere's ability to connect with standard storage technologies including SANS, NFS, and iSCSI, and you have a very flexible and robust storage environment. To manage this environment, vSphere includes vSphere clients that are easily accessible through the vSphere web interface, using most common web browsers, and in most cases without requiring any additional software installations. Okay, so that's it for now. Please make sure you review this week's module to ensure you don't miss out on anything, including the readings, labs, and other activities. Enjoy!